Hi everyone, today we're having a look at tree diagrams and the counting principle and how they are used in probability. The tree diagrams can be used to find the probability of two or more events. The counting principle can be used to find the number of possible outcomes and probabilities. Using tree diagrams in probability problems. Suppose you roll a dice and then toss a coin. What is the probability that you will get an even number and tails? Well, the possible outcomes when we roll a dice are 1, 2, 3, 4, 5, and 6. The possible outcomes when flipping a coin is heads or tails. So for every possible outcome of rolling the dice, we will also have an outcome for flipping a coin because we are performing two events. So we have a possible outcomes of a 1 and heads, a 1 and tails, a 2 and heads, a 2 and tails, a 3 and heads, a 3 and tails, a 4 and heads, a 4 and tails, a 5 and heads, a 5 and tails, a 6 and heads, or a 6 and tails. So all in all, there are 12 possible outcomes, but there are only 3 favorable outcomes because we are looking at the probability of an even number and then tails. So 2 and tails, 4 and tails, and 6 and tails are the favorable outcomes for the event even number then tails. So there are 3 favorable outcomes and 12 possible outcomes, which can be simplified to 1/4. So the probability of even number and then tails is 1/4. We could also write it as a decimal, 0.25, or we could also write it as a percent, 25% chance of rolling an even number and then landing on tails. Using the counting principle. Let's say we have a dessert special that offers 1 scoop of ice cream, 1 topping, and 1 cone for a special price. The possible flavors of ice cream that you can choose from for this special is vanilla, chocolate, strawberry, banana, and peach. The possible toppings you can choose from for this special are fudge, sprinkles, and cherries. And the possible cones you can choose from for this special is waffle cone and sugar cones. So to find the total number of combinations, we multiply the flavors by the toppings by the cones. So there are 5 flavors, there are 3 toppings, and there are 2 cones. If we multiply this together, 5 by 3 by 2, we have 30 possible outcomes, 30 possible combinations of different desserts using this menu here. Finding a probability using the counting principle. The president and treasurer of a club are randomly chosen from the names shown. What is the probability that both are female? And to make it easier for you, I've written the female names in pink and the male names in blue. So possible people to be chosen from the presidents are Sarah, Brad, Melissa, and Jessica. 3 females, 1 male. Possible people in the treasurer list are Chris, Anna, and Brian. 1 female, 2 males. So if we look at how many presidents could be chosen to fit our probability of all being female, both being female, we have 3, Sarah, Melissa, and Jessica. And 1 treasurer that could be chosen to have both being female, so that's Anna. So we multiply 3 by 1, and there are 3 possible pairings for the combination of both being female. So we could have Sarah and Anna, that's 1 possible pairing. We could have Melissa and Anna, that's another possible pairing. And we could have Jessica and Anna, and that's 3 possible pairings. In total, if we are looking at what the possible outcomes were, we would have 4 presidents to choose from because there are 1, 2, 3, 4, and 3 treasurers because there are 1, 2, 3 treasurers. So we multiply those together to find the total number of possible outcomes, which is 12. 3 represents the number of all female outcomes, and 12 represents the total number of outcomes. So the probability of both being female is 3 on 12, or simplified to 1 on 4.